Hi everyone. In this lesson we're going to be proving that two triangles are congruent using the angle side triangle congruence criteria. And this criteria says that if two angles in a non-included side of one triangle are congruent to two angles in a non-included side of a second triangle, then the two triangles are congruent. So notice here that you have two consecutive angles in one of the sides that is not included between these two angles. So this side, or it could be the other one, as long as the side is not included between the two angles. So angle, side, and the same thing on the other triangle, angle, side. These criteria, it's really coming from angle, side, angle, because notice that if the two triangles have two angles that are congruent, then the third angles must be automatically congruent. Like B, it's automatically congruent to angle E. Now why? Because let's say this angle measures, I don't know, let's say 50 degrees, and this one 30 degrees. Well, since angle D is congruent to angle A, this has to be also 50, and F is congruent to angle C, so this one has to be also 30. Now, if we use the fact that the three interior angles of the triangle add to 180, then we know that angle B is 100 degrees. And using the same reasoning, the fact that the three interior angles of the triangle add to 180, we also find that this is 100 degrees. So you can see that if two angles of a triangle are congruent to two angles of the other triangle, then the third angles are also congruent. That is actually a theorem. It's called the theorem about the third angles of the triangle. So we see that this angle here is congruent to this angle here. And if that is the case, then what we really have is angle, side, angle, side, angle. So the angle, side criteria, it's really coming from angle, side, angle, or in other words, it's a variation of the angle, side, angle criteria, and that's why it works. So let me just erase that, or I could leave that. So that's why it works, because the methods that we have here is not just whatever you want, it's what will create congruent triangles. So let's just review the methods that we have. We have so far side, angle, side, angle, side, angle, side, side, side. And today's method, which is angle, side, the proofs that we have here today are all using this method. But these are not any random methods that I have created. These are really methods that create congruent triangles. For example, let's say I have one triangle and you have not seen it. You have not seen it. And I give you three measurements only. I give you the measurement of two sides and the angle in between those two sides. And if you use those three pieces of information, you should be able to create a triangle that is exactly like the one I have, even if you haven't seen it. And the same thing happens with all these four criteria. These methods allow us to create congruent triangles. So they are not just any random methods, and therefore you cannot come up with any method. You cannot say, for example, okay, I'm going to prove congruent triangles using side angle, for example. That is absolutely wrong. That's not a method for creating congruent triangles, so you cannot use whatever you want. These are the methods that we have so far, and today's method is angle, side. And I'm going to do proof number 1 here. But before we do that proof, I just want to go over some important things based on the mistakes that I have seen that students are doing on the homework. So these are some things that you must do. First, you must mark the diagram. And the diagram should be marked with the information that you are given and whatever conclusions that you can get from the given. That is what should be marked on the diagram. The only thing that should not be marked is, for example, in number 1, we have proved that these two angles are congruent. That's the only thing that should not be marked because we do not know that they are congruent. We're trying to prove that they are congruent. Whereas whatever is given, we know that that is true because that's given to us. So we know that that is true and therefore we mark it. So the givens and whatever you can get from the givens should be marked. That's 1. Number 2, you must include the givens on the proof. Like in this one, we have all these givens. These givens must be included, must be written down on the statements of the proof at some point because you're getting some things from these givens, therefore these givens have to be there. Otherwise, you cannot write whatever you are getting from here because you did not include that. So you must include all the givens in the proof. Number 3, you must get what the criteria needs in order to prove that the triangles are congruent. For example, if you are using angle, side, you must get, and it has to be, and these things have to be mentioned, stated in the statements of the proof that you have 2 pairs of congruent angles and a pair of congruent sides, and the pair of congruent sides in this case is a side that is not included in between those 2 angles. So you must get whatever their criteria needs. You cannot just have whatever you want and say, oh, I have this criteria. No. And in order to make sure that I have the criteria that, or I would say, in order to make sure that I have the things that the criteria needs, I usually go writing an S or an angle next to a pair of angles that I have congruent or next to the pair of congruent sides that I have. So if I have angle, or I would say segment AB congruent to segment DC, for example, I write an S next to it just to make it clear that I do have 1 pair of congruent sides. And you can see here, these are sides, and I'm saying congruent. You cannot just have whatever you want and then write an S on it. That is not correct, because just writing an S doesn't make it correct. For example, I have seen some students having this AB parallel to DC, and then they write an S next to it, but that is not a pair of congruent sides. And just writing an S next to it, it doesn't make a pair of congruent sides. So this is absolutely wrong. In order to write an S, you must have a pair of congruent sides. Or in order to write an A, you must have a pair of congruent angles. Otherwise, it's incorrect. And the next thing, you must prove that you have congruent triangles before proving congruent sides or congruent angles, such as in our proof number 1, our final objective is to prove that those 2 angles are congruent. So before we do this, you need to prove that you have 2 congruent triangles. There's no other way around. Before proving sides or angles congruent, you must prove that you have 2 congruent triangles. And then if you have the triangles congruent, then the pairs of sides which are corresponding and the pairs of angles that are corresponding should be congruent automatically by CP/CTC, which means that the corresponding parts of congruent triangles are congruent. And of course, in addition to all of this, you need to review, you must review the definitions and theorems. Okay, so you cannot just write whatever you want from a given, conclude whatever you want from a given. No, you have to conclude whatever is correct. So you need to review the definition so that you can get what is correct. So with all this in mind, let's go to our proof number 1. And of course, the instructions say, write a clear and organized 2-column proof using angle-side criteria, using the angle-side criteria. This is our criteria for today and the only one that we're going to be using for all the proofs here. So number 1, given BC is perpendicular to CD, BA is perpendicular to AD, and BDE bisects angle CBA. So talking about reviewing the definitions, you need to know what's the definition of perpendicular lines and what do you get from that. Perpendicular lines that intersect to form right angles. When you get from here right angles, that's it. You do not get congruent angles, you get right angles. And now the definition of a bisector, but notice here, what is being bisected? An angle is being bisected. So you need the definition of an angle bisector. An angle bisector is a segment, a ray, or a line that divides an angle into 2 congruent angles. So it depends on what is being bisected. Here, an angle is being bisected. The result should not be congruent segments. It's impossible. You are bisecting an angle. How could you get congruent segments from here? If an angle is being bisected, you get 2 congruent angles as a result. So very important to know what the definition says. And then you have to prove, the final objective is to prove that angle CDB is congruent to angle ADB. So I'm just putting a dot here just to identify what is it that we have to prove at the end, but I'm not marking them congruent because we do not know that they are congruent. So it's angle CDB CDB congruent to angle ADB. So we want to show at the end that this small angle here is congruent to that small angle. I'm just putting a dot, but I'm not marking them congruent. Now let's see what we have. We have that BC is perpendicular to CD. Okay, so that those two are perpendicular, and when we have perpendicular lines, we have right angles. We get right angles. So I have a right angle here, over there. I'm marking the givens. And then I have that BA is perpendicular to AD. So one more time, perpendicular lines give us right angles. So this is a right angle. And then there is a theorem that says that right angles are congruent. So we know that this angle A is congruent to angle C because that theorem says that, not because they are perpendicular lines. Okay, so using that theorem, we have one pair of congruent angles because we want to get angle side where the side is not in between the two angles. So we have already one pair of congruent angles. But notice what I said. We're saying that they are congruent because there is a theorem that says that right angles are congruent. And then the other given says that BDE bisects angle CBA. So this big angle here is being bisected. That means that this big angle here is being divided into two congruent angles, and that those two congruent angles should be the little ones that you see here, CBD and ABD. So because BDE is a bisector, is bisecting angle CBA, then we know that this angle here is congruent to this angle here. So we know, or we have another pair of congruent angles, check. And so I just need a side that is not included in between the two angles. So I cannot use this side, for example. It has to be either this side here or this side here. But as you can see, this side here is the same for both, which means that they have a congruent side in common. So I have already the side. And I'm using this one with the reflexive property. So I already have now angle side, and therefore these two triangles would be congruent, and after we state that they are congruent, we automatically say that the corresponding angles here are congruent because the corresponding parts of congruent triangles are congruent. So now we write, because we have analyzed, we have planned, we already know what is it that we're going to write and how are we going to go starting from the givens all the way to the end. So I'm going to start by writing the givens the same way that I did on the plan. So I have that BC is perpendicular to CD and BA is perpendicular to AD. And we can put these two givens in the same because we could also get the results, which are going to be the same result, that you have right angles. And so you're going to have the same reason to justify, so you can put that together. So this would be given. And then what we get from these two segments being perpendicular, we get a right angle, angle C. And since there is only one angle at this vertex, you could say angle C. Like here, you cannot say angle B because there's not only one angle at this vertex, there are many angles. So you could say in this case, angle C. So I'm going to say, or you could name it using the three letters B, B, C, D. Angle C. And what do I get from these perpendicular lines? I get angle A, which is also a right angle. So angle C and angle A are right angles. Right angles. And I get this from the definition of perpendicular lines, because that is what the definition says. Perpendicular lines are lines that intersect to form right angles. And now there is a theorem that says that all right angles are congruent, and here I have mentioned two right angles. So in the next step I can say these two right angles are congruent because there's a theorem that says that. So angle C is congruent to angle A because all right angles are congruent. And we do not have a name for this theorem, so there's no way that you can just write a name. You have to write the theorem itself. And now you can see here I have a pair of congruent angles. Now I can say I have that, A, one pair of congruent angles. If you do not have a pair of congruent angles, do not write that. Okay, so basically we have finished with this given. We have here everything that we can get from this given. Now let's go to the next given. So we write down that given because we're going to get something from that. So BDE bisects angle CBA, and that's given. And what we get from an angle bisector, we get two congruent angles, which are marked here. You do not get congruent segments. So the angles that are congruent are angle CBD and angle ABD. Those two are congruent. So angle CBD is congruent to angle ABD. Why? Because I have a bisector. An angle bisector is mentioned on the previous stage. Definition of angle bisector. Be very specific. There are two types of bisector. You have to identify what type of bisector we have. We have an angle bisector. And so if, for example, you do not have mentioned previously in any of the steps that you have an angle bisector, there's no way that you could write here this as the reason, because you never say that you have a bisector. So if you have to write this, that means you should have a bisector mentioned somewhere in the proof, and that's why the givens have to be mentioned in the proof. They have to be included in the proof. So I have here then the second pair of congruent angles. There, these are two angles and they are congruent. So I can say now, hey, so I have angle. The only thing that I'm missing is the pair of congruent sides, which is BD congruent to itself by the reflexive property. So I write that BD, and since the rigid motion that would justify this congruence would be a reflection on this segment, I can mention exactly in the same way, BD, BD, because if it is a rotation, you have to exchange the letters. So BD is congruent to BD by the reflexive property. And now I have mentioned here sides that are congruent. So I have a pair of congruent sides, so I can say S here. And now I have angle side, so I should be able now to write the conclusion that these two triangles are congruent, not the final conclusion, just the conclusion that the two triangles are congruent. So triangle CBD is congruent to triangle ABD by the angle side criteria. So whenever you mention a criteria, you should have a pair of congruent triangles, not angles, not sides, because these criteria are not to prove congruent sides or congruent angles, they are to prove congruent triangles. And then, since these two triangles are congruent, any pair of corresponding sides should be congruent, especially this one that we want to prove congruent. So now we can say angle CDB is congruent to angle ADB by CPCTC, which is corresponding parts of congruent triangles are congruent. That's why in order to use this, you need first to prove that the two triangles are congruent. So CPCTC comes after a congruence criteria. It cannot come before. Okay, because we know that if you have two triangles that are congruent, then all the parts are congruent. So here is what we have. We have proven our final conclusion. Notice how many steps, 8 steps. You need to include all the givens, and you have to write what you get from the givens, prove that the two triangles are congruent, and then the sides or angles that you want to show that they're congruent. Okay, so basically this is the only one that I'm going to do. You have the following 3 exercises, which are exercise 2. It's a relatively simple one. You have this given, the other given here, and you have to show that angle SRT, this one here, is congruent to angle URT, the same way that we did on the top. You first need to prove that the two triangles are congruent before saying that these two angles are congruent by CPCTC. And you also have in page number 2, you're given here perpendicular lines. We just did an example with perpendicular lines. You have parallel lines, and you do have to remember what you get from parallel lines. You have alternate interior angles, corresponding angles, same side interior angles. And then you don't have to prove a pair of congruent sides or a pair of congruent angles. You only need to prove that the two triangles are congruent. So this should be one step less compared to the one that we did. And in the next one, you one more time have parallel lines or parallel segments in this case. So you also need to remember what type of angles you have: alternate interior angles, same side interior angles, corresponding angles, and B is the midpoint of DE. And in this case, you do have to prove that segments are congruent. So you are proving that this one here, it's congruent to this one here. And again, you have to prove that the two triangles are congruent before saying that these two segments are congruent. So this is your homework, exercises 2, 3, and 4. And that's it for today's lesson on how to use the angle side criteria to prove triangles congruent.